Cambridge iGCSE Chemistry, moles reacting masses. So here is an overview, but do remember to be active. That is, take notes, complete the tasks by pausing the lesson, taking your time, thinking the problems through. We'll start with stoichiometry. Convert mass into moles and moles into mass, and then apply that to reacting mass calculations. Stoichiometry is the ratio in moles of the reacting substance and the substances formed in a chemical reaction. Balanced chemical equations include this reacting ratio. So if we look at two magnesiums, one oxygen molecule, two magnesium oxides, is best interpreted as 2 moles of magnesium reacting with 1 mole of oxygen molecules to form 2 moles of magnesium oxide. That mole ratio, 2 to 1 to 2, is fixed regardless of the amounts involved. We can use the balanced chemical equation with the reacting mole ratio, 2 moles of magnesium reacting with 1 mole of oxygen molecules to form 2 moles of magnesium oxide, to predict, for example, how many moles of magnesium oxide would be formed from a starting 4 moles of magnesium. Well, to model this, 2 moles of magnesium forms 2 moles of magnesium oxide. That is a fixed ratio. So 4 moles of magnesium would form 4 moles of magnesium oxide. 2 forms 2, so 4 would form 4. Pause the lesson and complete the predictions for problems 2, 3 and 4 from different starting amounts. How many moles of magnesium oxide would be formed? Think it through, come back to check when you are ready. Okay, so 0.5 moles of magnesium would form 0.5 mole of magnesium oxide. 0.5 moles of oxygen would form 1 mole of magnesium oxide. It's a 1 to 2 ratio. 1 mole of oxygen forms 2 moles of magnesium oxide. Half a mole of oxygen forms 1 mole of magnesium oxide. 0.125 moles of oxygen obviously would form 0.25 moles of magnesium oxide. Converting mass into moles and vice versa, moles into mass. Converting mass into moles relies on the idea of molar mass, that is the mass of 1 mole, which is obtained from the relative molecular mass or formula mass expressed in grams. We then apply a simple formula. The numbers of moles is the mass of substance divided by the molar mass. So I'll do an example. Calculate the numbers of moles in 48 grams of magnesium. Well, 48 grams is the mass of substance. The mass of 1 mole is the relative atomic mass of magnesium, which we find in the periodic table at 24. So express that in grams, 24 grams. So 48 grams divided by 24 grams gives us an answer of 2 moles. 48 grams of magnesium is 2 moles. Can you solve the next problem? Pause, solve the problem, come back to check. Okay, so to reveal, generally chemistry will leave out the unit and just do 1.2 divided by 24. 1.2 is the mass of magnesium, 24 is the molar mass of magnesium. comes to 0.05 moles. Try these next two problems, 22 grams of carbon dioxide and 1.1 grams of carbon dioxide. How many moles in each case? Pause the lesson, produce your answer, come back to check. Okay, so 22 divided by 44. 44 comes from the relative molecular mass of carbon dioxide. Each carbon is 12 and each oxygen is 16, which we find in the periodic table. So 12 plus 32 comes to 44. So we have 0.5 moles. 1.1 grams of carbon dioxide, 1.1 divided by 44. You'll notice the relative molecular mass doesn't change. Of course, it's fixed for a particular compound formula. So 1.1 is the mass of substance, comes to 0.025 moles. So from the previous slide, the numbers of moles is the mass of substance divided by the molar mass. Now, a simple rearrangement of that equation gives us the mass of substance as the subject. Mass of substance is equal to the numbers of moles times the molar mass. So let's do a couple of examples. What is the mass? Calculate the mass. What is the mass of 0.3 moles of magnesium? Well, I'll model this. 0.3 is the number of moles. The molar mass is 24. So the mass of 0.3 moles of magnesium is 7.2 grams. Pause and evaluate 0.005 moles of magnesium. Come back to check when you're ready. Okay, so numbers of moles times 24 comes to 0.12 grams. Can you evaluate the mass of 2 moles of carbon dioxide and 0.025 moles carbon dioxide? Pause, calculate, and come back to check. Okay, so 2 moles of carbon dioxide is simply 2, the numbers of moles, times 44, the molar mass, 88 grams. Next problem, numbers of moles, again, times 44 comes to 1.1 grams. Well, now the real meat of the lesson, reacting mass calculations. We can use a balanced chemical equation and the reacting mole ratio, 2 calcium to 1 oxygen to 2 calcium oxides, to, for example, predict how many moles of calcium oxide will be formed from the complete reaction of various starting materials. So I'm going to model the calculation for problem number 1. How many moles of calcium oxide formed from 4 grams of calcium? Well, we're going to use the reacting mole ratio 2 to 2, but of course we need to convert grams into moles. So 4 divided by the molar mass, 40, gives us 0.1 moles of calcium. That will form 0.1 moles of calcium oxide. 2 forms 2, so 0.1 forms 0.1. Problems 2 and 3, pause, calculate the moles of calcium oxide formed from these starting materials. Come back to check when you are ready. So I'm going to reveal, convert 0.5 grams into a numbers of moles by dividing by the molar mass, 0.125. It's a 2 to 2, 1 to 1, 0.125 to 0.125 reacting mole ratio. So 0.125 moles of calcium oxide formed. 0.125, calcium forms 0.125 moles of calcium oxide following the reacting mole ratio. I'm going to reveal number 3. We need to convert the mass of oxygen into numbers of moles, but we're using O2. Molecular oxygen has a molar mass of 32. So 0.16 divided by 32 gives us 0.005 moles of oxygen molecules. The reacting ratio is 1 oxygen to 2 moles of calcium oxide. So we're going to double the numbers of moles of calcium oxide compared to the moles of oxygen. So 2 times 0.05 is 0.01 moles of calcium oxide formed. So we will go one step further to complete the calculation. Instead of predicting the moles of calcium oxide formed, predict the mass of calcium oxide formed from these starting materials. So I'm going to model the first calculation. 4 grams of calcium is 0.1 moles of calcium. That will form 0.1 moles of calcium oxide, and we need to convert that into a mass, numbers of moles times molar mass from previous slides. Numbers of moles times molar mass comes to 5.6 grams. The molar mass of calcium oxide, 40 for calcium, 16 for oxygen, comes to 56. So 0.1 times 56 is 5.6 grams. Could you complete the two problems? For 0.5 grams of calcium, what is the mass of calcium oxide formed? And similarly for 0.16 grams of oxygen. Pause the lesson, complete the calculation, come back to check. Okay, so I'm going to reveal 0.5 grams of calcium is 0.125 moles of calcium. So the reacting mole ratio tells us that will form 0.125 moles of calcium oxide. And then for the mass, we do numbers of moles times formula mass, or molar mass, I should say. Comes to 7 grams. If you haven't done problem 3, pause and complete it. Otherwise, here is the solution. 0.16 is 0.005 moles of oxygen. That will form twice that numbers of moles of calcium oxide. It's a 1 to 2 ratio, as we explained on the previous slide. The third step is to multiply the numbers of moles times the molar mass, comes to 0.56 grams. So here are two problems of a slightly different nature. Predict the mass of calcium required to form 1.12 grams of calcium oxide. So here you are given the mass of calcium oxide. What mass of calcium is required to form that mass? So I'm going to model the first problem. 1.12 grams of calcium oxide is 0.02 moles of calcium oxide. So we need to convert the mass of calcium oxide into numbers of moles. We achieve that, if it isn't clear to you, by doing 1.12, that's the mass of substance, divided by 56. So that comes to 0.202, I should say. Now, having got the moles of calcium oxide formed, we've now used the reacting ratio in reverse. It's 2 moles of calcium oxide come from 2 moles of calcium. So 0.02 moles of calcium oxide requires 0.02 moles of calcium. So we now get the mass of calcium by numbers of moles times molar mass, comes to 0.8 grams of calcium. So 0.8 grams of calcium would form 1.12 grams of calcium oxide on complete reaction. Could you try problem number 2? What is the mass of oxygen required to form 0.5 grams of calcium oxide? Pause the lesson, attempt the calculation, come back to check. Okay, so to reveal, We convert the mass of calcium oxide into moles. We're going to multiply the moles of calcium oxide by 1/2 to give us the moles of oxygen. 2 moles of calcium oxide come from 1 mole of oxygen molecules. So we achieve the numbers of moles, 4.47 times 10 to the minus 3 moles of oxygen required, but we're asked for the mass of oxygen. So numbers of moles times molar mass gives us the mass of oxygen. This topic in particular requires practice, so find problems in your textbook or other source for which you have access to answers. Then move on to past paper questions. If you have benefited from this lesson, please subscribe if you feel able. Please recommend this lesson or channel to a friend. Thank you for your help.